In Java, every object has to be born. If you don't provide a specific set of birth instructions, the system doesn't ask questions. It simply hijacks the delivery process and makes its own choices. Think of it like a video game where a character spawns with exactly 0 hit points. Because the system didn't have instructions for health, it defaults to the lowest possible value, and your player dies the millisecond they enter the world. This is the work of the implicit default constructor. It's like an overcaring parent who sweeps through your room while you're asleep. It clears out the garbage, but it has no situational awareness. It just resets everything to a blank slate without checking if you actually needed those values. On the left of this diagram, we have an empty player class. On the right, you can see what happens behind the scenes. That sweeping animation shows the default constructor forcing integers to 0, booleans to false, and strings to null. It clears out the data you actually need to keep the object functional. Relying on this automatic housekeeping leaves your objects built on null and void promises. To make sure an object survives its first frame of existence, you have to take manual control of that baseline. The first way to reclaim your code is by writing a user-defined no-arg constructor. When you explicitly write a constructor that takes no arguments, you're telling Java to step aside. This prevents the system from applying its own default values and allows you to set the rules for what standard looks like. In this code snippet, we've defined a custom player constructor. Now, instead of starting at 0, every player is born with 100 HP and their is alive status set to true. Now, when the game spawns a character, they arrive fully equipped and ready for combat, rather than appearing in the generic gray sweatpants the system tries to force on them. By defining this baseline yourself, you ensure the object's identity is protected the moment it's instantiated. Hard-coding the same stats for every object only works if everyone is supposed to be identical. Real-world systems require unique data at the exact moment of creation. In a banking app, if you initialize an account with a placeholder like pending user, you create a window for data corruption. If the system crashes before you can update that name, you're left with a legal account that has no identifiable owner, making it impossible to audit or secure. The parameterized constructor solves this. It allows the object to announce its specific requirements, like a name and a deposit amount, at the very second it's born. This syntax passes unique data directly into the constructor. Notice how the owner's name and initial deposit pass into the parentheses and assign to internal fields. The highlighted dis keyword acts as a pointer, ensuring we assign incoming parameters specifically to this individual account. Using these parameters ensures that objects aren't just generic placeholders, they are fully functional, unique entities from their first millisecond of life. However, taking control comes with a catch. As soon as you write a parameterized constructor, Java permanently deletes the implicit default constructor. Because you've provided specific instructions, the overcaring parent assumes its help is no longer wanted. It packs its bags and leaves your code for good. Look at this error. If you try to create a new account without providing arguments, the program crashes. The system no longer knows how to build a standard account because the default housekeep usurping service done. This stops the entire compilation process. It's a class action drama where your code refuses to run because you've removed the safety net without providing a backup. In Java, once you start customizing the birth of an object, the system expects you to handle every possible scenario yourself. To fix this, we need to bridge the gap. We need to support both specific, unique inputs and those simple, empty calls that our program might still rely on. We do this through a process called constructor chaining. In this diagram, we've added a no-arg constructor back in, but instead of rewriting the logic, we use the this keyword as a function call to route that empty request straight into our parameterized constructor with default values like default and 0.0. Watch the data packet. When an empty account is requested, it enters the first constructor, hits that this call, and is immediately redirected. It fills the requirements of the parameterized constructor and finishes the initialization without any errors. Using chaining allows you to maintain a single source of truth for your object's logic, while keeping your code flexible enough to handle any situation.